In this video, we're going to focus on condensation polymers. Now, in particular, we're going to look at polyesters. So before you watch this, I suggest you go back and have a look at esters again, because you'll need to know how to draw those before you'll fully understand how to draw a polyester. Now, I'm just going to refresh your memory about the first type of polymerization that you would have seen. So you should hopefully remember the addition polymerization, which is where you need an alkene, which is our monomer, and we stick many of them together to make our polymer here. So you've only got one type of monomer, add together to make your polymer here. Now in condensation polymerization, it's slightly different because you have two different monomers. They'll form together to make one polymer, but also you get a waste product, a small molecule that's being lost in this reaction. So if you can remember from esters, you'll need an alcohol and a carboxylic acid. Now the difference with a polyester is that you need a diol. So you need an alcohol with two OH groups on it. You'll need a dicarboxylic acid as well. So you need two carboxylic acid groups. And your product is going to be a polyester. And again, the other difference with addition polymerization is you get one waste product as well. So you get water being produced from this reaction. Let's have a look at a couple of examples to see what it looks like when you're drawing polyesters. So, first of all, let's start off with a simple alcohol. So we're going to do methane diol. So we've got two OH groups on it. So methane diol. The di meaning it's got two. We're going to add this to our carboxylic acid. So we need a dicarboxylic acid in this situation. So if we put it with two carbons in the chain, that means we've got dicarboxylic acid, so we're going to have ethane dioic acid. Now if you remember from drawing an ester, we've got the oxygens left on the carbons. These OH groups go off to form water. So we've got two of those being lost. We're going to lose this one and we're going to lose this one. If we look at the alcohol, we lose the two hydrogens from the alcohol and the oxygens remain behind. So here's our polyester now. Now to show that this is a repeating unit, we'll put some square brackets around there and show that this repeats any number of times. That means we need n number of these to make this polymer. Now you'll see that means for each time this happens, we should produce two water molecules. If you add all this together, we produce two more water molecules for every single time this happens. So if it happens n times, there are 2n water molecules being produced for this reaction. Let's have a look at another example with a slightly different alcohol, but we'll use the same carboxylic acid. So for this time, we're going to use ethane diol. So we've got two carbons in the chain this time with our two alcohol groups. So we've got ethane diol. We're going to need n number of them, and we're going to react them with n number of our carboxylic acid, and we'll use the same carboxylic acid for this reaction. So we're going to use ethane dioic acid again. To make our ester, you're basically looking for the same thing in the structure. So the oxygens remain, the double bonded oxygens remain. The OH groups are going to go and form water. The oxygens remain on the alcohol group. And then two water molecules, two N water molecules are released and lost every single time this reaction happens. So we need N number of these to be produced. Now, there's one more thing to talk about here. If we have a look at the number of water molecules that are getting made, now it's fine at GCSE to include it like this, but some of you may have noticed that at the end, you would actually need to finish the molecules off. Now, in reality, what would happen is when many of these have added together, the ends of these chains are going to be completed by adding on the hydrogen and the OH groups that they would normally have if they were carboxylic acids and alcohols. So to get the balancing right, what you would actually have is 2N minus 1 water molecules for the balancing. And that's because one of the water molecules, there's one hydrogen there, the other hydrogen here, so that's H2, and the other oxygen is there. That would finish off the polyester chain normally. The final thing to look at is just having a look at the names of these polyesters. Now we can name them in the same way that we're going to name a ester normally. So we look for our side group coming from our alcohols, and then we look at our main chain coming from our carboxylic acid. So for this example here, we've got 2 carbons in our side group. So this is our ethyl group. The carboxylic acid is our ethan O8. And then it's just a polymer. So we just put poly at the front. So we've got polyethyl ethanoate. If we look at this one here, again another polymer. So this time we've got the methyl group is on this one because we've got 1 carbon in the alcohol group. So methyl. We use the same carboxylic acid for this one. So this is an ethan O8 again. But because it's a polymer, we just want to put that into brackets and put polymer or poly at the front to show that it's a polymer. Now thanks for watching the video. Please remember to like, subscribe to the channel, share the videos and keep watching.